Hi students, in this video we'll be discussing about Hadoop MapReduce framework and we'll be learning about the Hadoop MapReduce model and the MapReduce parallel data. And here we can learn about this MapReduce parallel data flow. You have a data flow diagram and you can learn about it. This parallel execution, as I said, this MapReduce, implementing this MapReduce algorithm is parallel execution. It has 5 steps: input splits, map step, combiner step, shuffle step and reduces step. Input splits, map step, combiner step, shuffle step and reducer step. Now we can see this parallel MapReduce data flow diagram. As you know, there are 5 steps: input split, map step, shuffle step, combiner step, reduce step. You know, one of the main feature of my distributed file system is maintaining multiple copies. If there are 8 or more than 8 nodes in a cluster, replication factor is 3. That is, in 3 nodes the data will be available. If the number of nodes in a cluster, if it is less than 8, replication factor is 2. That is, same data is available in 2 more nodes. Now, these maintaining multiple copies is physical boundaries. Now coming to the logical boundary of my input. If my input data is huge, if it is a large volume of data, I can have logical boundaries. Usually this logical split of my input file will be less than the data block size. You know, the block size of data is 64 MB to 128 MB. So this input split will be less than this block size. Less than this block size. So here, how many input splits are available? I'll be having same number of mapping. In this example, this is my input file. This input file I have made into 3 splits. I have taken a simple example, 3 lines, 3 words per line. So I have made 3 splits and I'll be having 3 mappers. Right. So the number of mappers will be equal to the number of splits. What about this splits? It is logical split of my input data, and you have to remember this split size will be less than my data split. Data block size. This split size will be less than my block size. I'll tell it once again. Split size will be less than my block size. Right, and you know, number of mappers will be equal to the number of splits. That is one thing. Now, to assign this mapper to the splits, you have to find the server that is having this data. Right, server which is having the data, and you know it will be having multiple copies. So I have to find the least busy node that is having the data. If all the nodes that is having the data is busy, what you can do is you can find the nearest node. What do you mean by finding the nearest node? Data available in the same rack. What do you mean by rack? All the data nodes that are connected to the same network switch is said to be in the same rack. Data nodes connected to the same network switch is said to be in the same rack. So first try to find the server which is having the data, and it should be a least busy node. If all the nodes that is having the data is busy, then you can find the nearest node. If both are not possible, you can randomly choose the server that is having the data and you can assign the mappers. Once the mappers is assigned, you know what could be the output of this mappers. It will give you the list of key value pair. Right here, in this diagram, I have taken a file. I want to find the number of instances of each and every word in that file. I have to count the number of instances of each and every word in the file. So the output of this mapper will be key value pair C1 spot 1, run 1. Likewise here, run 1, spot 1, run 1, C1, the 1, cat 1. And next is, you can check the previous slide. Just a minute. After this mapper script, you have this combiner step. In combiner step is optional. Either if you want you can use it, otherwise you can drop it. And in shuffle step, what I will do, I will shuffle the instances, same instances to same node. See, this is my first C. So wherever C is there, I will move to the same node. Here C, I am moving here, and the third split is having C, so I am moving to the same node. Similarly, similar instances will be moved to the same node, and at last I will apply this reducer script and it will find the total of every word. And I said this combiner step is optional. This combiner step comes between the map step and the shuffle step. Comes between the map step and the shuffle step. In combiner step, what I can do is like I can combine. You take the second split here. I have two instances of run. So here you can combine run comma 2. If you want, you can do that. If you do it, it will lead to less amount of data transfer. If you do the combiner step, it will lead to less amount of data transfer. Otherwise, data transfer will be little more. But that combiner step is optional. If you want, you can do it. Otherwise, you can leave it. And then shuffle, reduce. So this is your data flow diagram for your MapReduce model. Hope you understood it. Thank you.